Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on rotting oranges. As many of you would know, it's a very frequently asked interview question. So let's jump into the problem statement, understand it and start solving. So last time we have solved the number of islands. You can find it in the list. We'll start with rotting oranges. With this, it reminds me that we have reached 41 out of 75 problems. So slowly we have reached 41. Okay, you can find all the videos in the list from Grind 75. Okay, let's start with the problem. Rotting oranges. You're given an M cross N grid where each cell can have one of three values: 0 representing an empty cell, okay, 1 representing a fresh orange, and 2 representing a rotten orange. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. Return the minimum number of minutes that must elapse until no cell has fresh oranges. If this is impossible, return -1. Okay. So they have actually clearly explained with this image diagram. Let's see. So this is rotten orange at minute 0. At minute 1, all the oranges adjacent in all the 4 possible directions. So there is nothing up on left. So on the right and the bottom, these two get rotten in after 1 minute. Similarly, when we move to second minute, orange adjacent to this one and adjacent to this one, it could get rotten because of this or this, right? So these two are affected as well. Similarly, after third minute, this one is affected. After fourth minute, the last one is affected because of this orange. So this answer is 4, right? Because 4 minutes. Now for this one, the solution says -1. So this is not possible. Let's understand why this is not possible. Okay. So we have 2 representing rotten oranges, 1 and 1. So 2 is for rotten, 1 is for fresh, 0 is for empty. 0, 1, 1 and 1, 0, 1. Okay. So because of this 2, this one will get affected. We'll change it to 2. This one will get affected. We'll change it to 2. Because of this one will get affected. We'll change it to 2. Because of any of these two, this one will get affected. We'll change it to 2. And because of this one will get affected as well. But this one is not affected, right? Because there is no adjacent rotten orange to affect this one. So this answer is -1. Okay. So with these two examples in mind, please take a minute, think of our approach before I start solving. Ready? Okay, great. So firstly, we can see the problem is in grid, right? 2D matrix. So what we can do is we can actually start traversing the loop from the left till the right bottom and count all the fresh oranges. Okay, let's say in the beginning all the fresh oranges are for this example 1 2 3 4 5 6. So we'll say fresh orange count, let's say. Okay, and we'll say 1 2 3 4 5 6, right? That is after one traversal. Similarly, what we will do is we'll keep note of the rotten oranges. So in this case there is only one here, but there could have been another one at this point as well, right? So we need to keep note of rotten oranges, right? Now, so this is all that we can do in one loop, right? After that, what would we want after that? So we found all the rotten oranges. We have the count of the fresh oranges. So what we'll do, we'll again start a traversal. Okay, we'll use and one by one for representing each minute. What we'll do from the, let's say we keep it in a queue. Okay, queue. So one by one we'll extract the coordinates of the rotten oranges and all in all the 4 possible directions, right, down, up, left, will affect the oranges, right? So they will be switched to rotten oranges, and similarly each time when a orange is switched to rotten orange, will reduce the count of fresh oranges, right? And this will do using BFS, let's say. So at this point from this for this rotten orange will affect this after 1 minute. And similarly in one loop, since all these three are getting affected, will now increment the minute. So now we know that 1 minute has passed. And similarly two of the oranges got rotten, so we'll reduce the count of fresh oranges to 4. So in the end, if the fresh oranges count reaches 0, that means we could reach all the oranges and now all of them have been affected, and total number of minutes would be the solution. In case by the end, if the fresh orange count is not equal to 0, that would mean that there exists at least one orange which has not been affected, so the solution is not possible, and will return -1. Okay, with this let's start coding. So we'll take our base condition. I think this is similar to the one that we solved yesterday on finding the number of islands. So if grid is equal to null, or grid dot length is equal to 0, that is the row length, and similarly grid of 0 dot length is equal to 0, that's the column length, we can simply return what should we return? 0, right? Then let's calculate the rows and columns just like yesterday. So int num rows is equal to grid dot length, and then int num columns is equal to grid of 0 dot length. What else? Int yeah, we'll create the we have the rows, we have the columns, so yeah, fresh oranges, int fresh oranges is equal to 0. And what else do we need? Yeah, we need a q as well. So q, what should be the type? We have to store the coordinates, right? So we'll say integer format, integer array, and q is equal to new linked list. Okay, now we'll traverse the grid. So traverse the grid, count the fresh oranges, and yes, add the rotten oranges to the queue, right? So let's start quickly. For int I is equal to 0, I is less than rows, I plus plus. Similarly for int j is equal to 0, j is less than num columns, j plus plus, right? Normal 2D matrix traversal. Now we'll see when fresh orange is encountered, right? How will we encounter? If grid of I j is equal to 1, that means we have encountered a fresh orange. So we'll increase the fresh orange count, fresh oranges plus plus, right? Else if grid I j is equal to 2, that means rotten orange. So we'll add the rotten oranges as part of the queue. Q dot add. How will we add? We'll create new int, we'll pass ij. Okay, that's it. So what do we have after this loop is, we know the fresh count of the oranges, that is 6 for the first case, or we'll consider this case actually. So what was this case? 2 1 1. Let's change it quickly. 2 1 1 1 1 and 1, right? So fresh oranges are 1 2 3 4 5 6. Now this rotten orange has been added to the queue. So we know I is equal to 0 and j is equal to 0 for this one. Okay, after this we'll check for the queue, and at once we want to update in all the 4 directions, so that we know that only 1 minute has passed and all the 4 directions have been affected, right? So let's create a variable for the minutes. Int minutes is equal to 0. Similarly, int will keep all the 4 directions equal to -1 0. Similarly, we'll have 1 0. Similarly, we'll have 0 0 -1 and 0 1. Right, now we'll perform the BFS on all the rotten oranges from the queue. So we'll say perform BFS to simulate rotting of or rotting oranges. Okay, so as long as we have elements in the queue, so while queue is not empty, right? And what else do we have to check? And we have to check that we have at least one fresh orange, right? Otherwise, what's the point of checking how much time it will take to rot all the oranges if all the oranges are already rotten, right? Okay, so we'll check that if fresh oranges is greater than 0. Now if it so happens, we'll calculate the size. Int size is equal to QUE dot size for why do we need this size? So if you cannot guess it at the moment, let's say we are at the first minute, right? At this moment 3 oranges are rotten, right? So we want to run the BFS in all the 4 directions for all these 3 oranges and then increment the minute by 1, right? For this one it will affect this and this, but we then want to perform for this one also and this one also, right? And only then 1 minute will increase. That's why we'll keep the size to run the for loop internally. So for let me leave some space. Int I is equal to 0. I is less than size I plus plus. Okay, we'll say int, we'll find out the current is equal to q dot poll, right? Now we have to check in all the 4 directions. So all the 4 directions will get from here. So for each of the rotten orange from the queue, the coordinate we'll check in all the 4 directions. So we'll say for int direction from directions, and we'll say int new row is equal to current plus the one that we get from direction, right? Similarly, int new column is equal to current 1 plus direction 1, right? Now we'll check the base condition before running the loop so that we know that it's not outside bounds. So if new row is greater than equal to 0, similarly, and new row is less than our main row, that is num rows, what have we named it? Num rows. Okay, num rows, right? Similarly, and new column is greater than equal to 0, and new column is less than num columns. What else are we missing? Yes, also, and we have to check if grid of new row and new column is equal to 1, because if it's not rotten already, we cannot affect it. Let me expand this. Yeah, okay. So if this happens, we'll mark all the adjacent fresh oranges as rotten, and we'll add them to the queue. We'll add the current node to the queue, new current node. So we'll say mark the adjacent fresh oranges as rotten. So we'll say grid new row new column, no column is equal to 2. Now that it is affected, and q dot add, we'll add this new int. I think I'm committing a lot of typos today. New row, new column. Okay, and we'll subtract the fresh oranges minus. Okay, that's it. Now once we have run this for loop, that would mean we have run this for loop for all the 4 directions of all the oranges in 1 minute. Then we will increment our minutes, right? You can say minutes plus plus, right? Let me expand this image on the right. So after each minute, like 1 2 3, after this we perform this DFS in all the 4 directions for all the oranges. For this one, top left right bottom. For this one, top left right bottom, top left right bottom. So these two get affected, and after this we increment the minute by 1, so it becomes 2 minutes, right? Once all of this is done, once we have done all the computations and everything is done, if at this stage our fresh oranges are not equal to 0, that means we have not affected all the oranges. That means the solution is not possible. If it is possible, we'll return the minutes. So we can say return fresh oranges equal to 0. If yes, we'll return the minutes, otherwise we'll return -1. Let's run it. So time complexity of the overall solution would be O of m cross n. That is the grid. It's running fine. Oh, I was actually thinking we'll get some typos. Okay, great. Beats 84.00% of users with Java. So I'm guessing there must exist a better solution than this one. Possibly, or don't, I'm not so sure. But if so, maybe they used another approach with the DFS or some other way rather than using the queue. But if so, please let me know in the comment section if you have a better approach than this one. Okay, so please go through this video again. This is a very frequently asked interview question. Okay, so with this, that's all from today's video, everyone. For anything, please let me know in the comment section, and in the end, please like, share and subscribe. Thank you.